Hello, this is AMET 104 lecture recording week 7.3. So last class we started the chapters 15.1 and 15.2, sorry, and we went over briefly about the percentiles, and we also went over means and how to find them. I would assume that finding mean is easy enough for most of you. So let's start this class by recapping how to find the percentiles, because I think a lot of students do have difficulties finding percentiles in the beginning. But once you get the hang of it, it's a lot easier than you think. So percentiles. So the first step, let me actually write the heading first, the percentiles. The first step is you gotta sort the data from the smallest to the largest. And let's denote it D1, D2, D3, to the N. So here, D is from the data point, and D1 means the first data point. In this case, since this denotes the sorted data, D1 will be the smallest data point of the data set. D2 will be the second smallest, D3 and D4, and the N is the biggest data point in the data set. So that's the first step, which is very straightforward and easy enough. The second step, and you gotta find a locator. Find a locator. And the function for the locator is given as such. L equals to P divided by 100, and you multiply that by the size of the data, or in other words, the number of elements in the set. So this actually represents that, so if P is a percentile number, P should stay between 0 and 100. So if you plug in any number between 0 and 100, this first is the decimal form of the percent, and you're simply multiplying that by the number of data points in the data set, and it'll simply show the location of the P% in the data set. So the third and last step, this is where it gets a little confusing. So this has two different outcomes. So if L is a whole number, then the Pth percentile is actually DL.5. So this, even though I do not really agree with the notation either, this is how they describe it in the book, means that it's simply the average between the DL and the L plus 1 divided by 2. So it's the average of this locator. So yes, average of this data point and the next data point, and you're simply taking the average. If L is not a whole number, then the pth percentile is given as D L plus, where L plus indicates the rounded number. So if it was 5.5, it'll be 6D6. Let me write, i.e. if L is, it's a 5 point, maybe write a 5.4, just to give you an idea. Then DL plus is D6. So we have done one example last class, and I think I may have rushed it a little bit. So I think it'll be a good idea to start the class going over the same example one more time. And I think I should be able to use the same data set for the following examples. So let's do that. Since we're going over for the second time, I'm going to go a little bit quicker. So example. So this is an example where there are 15 students in this specific athletic team, and if a student gets, so n equals 15, and if a student has GPA greater or equal to 80th percentile, and then they receive $5,000 scholarship. And if a student has GPA greater or equal to 55, so 55th percentile, then they receive $2,000 scholarship. Obviously, when we're talking about the $2,000 scholarship, we're excluding the ones who have already received the $5,000 scholarship earlier. So the data goes like this. So I'm going to just write the sorted data. So the sorted GPA would be 3.33, 3.35, 3.41, 3.42, 3.45, 3.57, 3.62, 3.65, 3.67, 3.71, 3.76, 3.82, 3.88, 3.91, and lastly 4.0. So In the problem, you are initially given, in most cases, that unsorted data, just like a raw data set without any order. And I just took the liberty to skip that part, but this is the sorted data. So this is sorted GPA. So we can see that we wrote from the smallest GPA of all, and we have the greatest GPA at the end. When you check the sorted data, make sure you do it a couple times to make sure that you're not skipping any numbers, because oftentimes that happens. So for the $5,000 scholarship, we can find the locator is 80th percentile. So it should be 80 divided by 100. And you're multiplying by the total number of data points in the data set. So in this case, it's 15. And we were able to calculate last time that this is 12. So the next step and the last step that you should be able to see is that since the locator here is a whole number, then we have the 80th percentile that's given as D 12.5. So how you find that is simply taking D12 and D13 and dividing it by half. And in this case, we can see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the D12, and this is D13. Excuse me. So simply, you can write 3.82 plus 3.88 dividing it by 2 should give you that it is 3.85, and that is your 80th percentile. So students who receive $5,000 scholarship would be 3.88 because you have to be greater or equal. There's no student who actually has the 3.85 GPA, but we have greater. We have 3 greater students, the 3.88, 3.91, and 4.0. So to repeat the step, we can simply go over the $2,000 scholarship. And the locator is 55 divided by 100 because it's the 55th percentile, and you're multiplying by 15. By plugging it into the calculator, you should be able to see that this is 8.25. And notice that this is not a whole number. So then we can conclude that 55th percentile is simply the data that's on the 9th, because we know that it's a rounded number from 8.25. And simply we can see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 3.67. So since it includes the 3.67, we can say that there are 4 students who are receiving $2,000 scholarship, and those GPAs are 3.67, 3.71, 3.76, and lastly 3.82. So this is what we did last time. So today we're going to do a couple more new stuff, but I'm going to keep this data because I want to use the same data set. So we can refer back to it later, but I'm going to skip this page for now. So the median and quartiles. So simply the median, let me actually do the definition separately. I think that may be better. Median is directly related to the percentiles, same as the quartiles, but let's go over the median first. So median is simply the 50th percentile of a data set. And as you can see, 50th percentile means that it's 50% of the data is smaller than median, and 50% of the data is greater than the median. So we can see that the median splits a data set into two halves. And that should be pretty intuitive. Knowing that it's a 50th percentile, it should have half of the data in the left, half of that on the right. And now let's talk about the quartiles. So after the median, the next most commonly used set of percentiles are quartiles, and TIL, yes. So the first quartile, there are two different quartiles. There's a first quartile and the third quartile. So the first quartile, which is denoted as Q1, is the 25th percentile. And the third quartile, which is denoted Q3 and is the 75th percentile. Oftentimes, the second quartile is the same as median, and obviously the fourth quartile is the 100th. But those have different names. So second quartile has a name median, and the 100th quartile, which is the largest of the data set, is just the maximum. So we don't really use the term second quartile or the fourth quartile. So now that we know the definition of the median and first quartile and the third quartile, let's actually try to calculate the of each of these numbers from this data set. So we already have a really nice sorted data. So here, let's first find the fifth, let's first find the median. So the median, so this often denoted as M. And let's find it. The median the above example you first gotta find the locator. And we know that it's 50th percentile. So you simply divide 50 by 100 and you multiply by the size of the data. As we can see that this is simply 1/2. And if you divide 15 by 1/2, you get 7.5. So we can see that 7.5 is not a whole number. So hence we have the median, which is, in other words, the 50th percentile. It's given as the 8. So let's go back up to the data and find the 8th data. So that's 1, 2, 3, 4, 5, 6, 7, 8. So we can see that it's 3.65. So the median of this data set is 3.65. And that's all there is to it. So as you can see, that since the median splits the data in half, oftentimes you don't really have to go through all these calculations. Even though it's very simple, you can simply see, and since you know the size of the data, you can simply find the middle value, the value that's right in the middle. But it is always more accurate to calculate the numbers. Let's find the first quartile. So the first quartile of the above example, we can simply do the locator, and we said that first quartile is the 25th percentile, so it should be 25 divided by 100 multiplied by 15, and that is 3.75. And since that is not a whole number, you can see the first quartile, which is 25th percentile, we can simply denote it D4. And the fourth smallest data is 3.42, and that is what the first quartile of this data set is. So lastly, the third quartile. It is simply the 75th percentile multiplying by 15. You can see that it is 11.25. And since it is not a whole number, excuse me, since it's not a whole number, it's the rounded number. The percentile is D12, and the 12th data in here is 3.82, as we can see here. So it's not that, it's 3.82. So now we know how to find any P percentile given the data set. And we also know that using that tool, we know how to find the median first quartile and the third quartile. Let's now go over a different concept or new stuff. And this is called the box plots. I'm sure some of you may have already heard of it, but box plots is a very useful tool when it comes to interpreting data set statistically. So a box plot is a picture. So a picture of the 5-number summary of a data set. The box plot consists of a rectangular box that sits right on top of actually right above is a better term. A number line representing the data values. And it extends from the first quartile to the third quartile. And a vertical line crosses the box indicating the position of the median M, and on both sides of the box are whiskers. and it's extending to the smallest value. Basically, this is called a min. And the largest value. And obviously this is the max. So I know that's a very descriptive paragraph, but you should be able to see that it's a very useful tool when I draw one, actually. It's actually quite simple. So let's draw the box plot of this example that we just went over. So box plot of the above example. So the first thing you gotta do is you gotta draw a number line. And I know I haven't really gone over what a number line is, but I would assume that number line is very intuitive for you, and I know some of you should already know what a number line is. And the number line really, you don't really have to indicate any point in the number line, but it's good enough to just draw one like this. And what I'm going to do is now draw a rectangular box like this. And each edge, left and right edge of the box is the first quartile and third quartile. So in this case, the first quartile was 3.42. So this should be 3.42. And the third quartile was 3.82. And remember, the median was 3.65. So it's a little bit closer to the third quartile, I guess, because the right in the middle is 3.62 and 3.65 is a little bit to the right. So here, I'm gonna draw this vertical line, and this actually is the median, and it should be 3.65. And even though I haven't really explained what the min and max is, it should be easy to see that the minimum value is the smallest value and the largest value is the largest value. And to my recollection, the largest is 4.0 and the smallest is 3.33. So the left end should be 3.33 and the right end of the whisker should lie at the 4.0. And this is the min and this is the max. And that's it. So because of how the homework problems are set up, also the quizzes and the exams are set up because they're all online, drawing one like this may not be as intuitive on the online platform. So most of the time, the problems that you'll see in homework quizzes and even maybe the exams, you are probably only asked to find the, like, just interpret the data. So for example, you're given a data set and you'll probably be given different choices and pick the correct box plot of this data set kind of deal. That's really the extent that you'll probably be asked. But it's a very useful tool, and it's very important that you understand and know how to draw it. Then interpreting it should be an easier portion of your job. So, that is the end of chapter 15.2. I want to go over 15.3 a little bit, but I think I'm going to end it here for now, because I think we could benefit from going over some of the examples before we go over 15.3. So 15.3 is actually very related to 15.2. So it's important that you understand everything from 15.2 to understand the 15.3. So I think I'm going to end it here. And next class, we're going to go over different examples that you might encounter in this chapter. Thank you for joining the class, and I hope you have a great rest of the day.